Hi everyone, Francis is here. In today's video, we'll continue with partial fraction decomposition. Here we'll take our example, example 4. The problem here says write the partial fraction decomposition of x raised to the power 3 plus 13x over x raised to the power 2 plus 2 all raised to the power 2. Now, like I said earlier in the earlier videos, before we can decompose this, another word for decompose or lose words, you can think of this decompose to mean like break into parts, break. So before we can decompose this expression or this partial fraction, we look at, is this a rational partial fraction? Is this a rational expression? Yes, it is, because the highest power of the numerator here is less than the highest power of the denominator here. Okay? Yes. Never mind that we have 2 here. When we multiply, this is x raised to the power 2 raised to the power 2. When we expand and open up this bracket, we would have x raised to the power 4 at the denominator, which is greater than, for the power of x being 4 here is greater than the power of x, which is 3 here. So with that, this is a rational partial fraction. So let's go over to the next step. The next step will be to look at the denominator. Is it already factored? If it is not already factored, we'll factor it. If it is already factored, we'll go over to looking into how we can break this into parts. But this is already factored. As you can see, this is an irreducible quadratic expression. Okay, it's an irreducible quadratic equation. And it is repeated in the sense that it is raised to the power 2. Okay, it could be raised to the power any, maybe n or whatever n factor. But the question is, how do we treat it in terms of decomposing it into parts? Now, how we do that is we write the right hand side, and then how we do that is, if these two were n, we'll start with x raised to the power 2 plus 1 raised to the power 1. The next one will be x raised to the power 2 plus 2 raised to the power 2. The next one will be x raised to the power 2 plus 2 raised to the power 3, on and on in that order to x raised to the power n. That is how we treat this. If it were linear, repeated, say x raised to the power 5, x raised to the power 6, or x raised to the power n, we'll keep dropping, starting with x raised to the power 1. The next denominator will be x raised to the power 2. The next denominator will be x raised to the power 3 till we get to n. Okay? Yes. And whereby our n is a real number. It's less than infinity, meaning it is finite. So having said that, the next step will be to, we distribute it in this way, like I said, x raised to the power 2 plus x raised to the power 2. Recall that I said whenever we have our denominator to take this value, whenever we have a denominator to be irreducible, the numerator will be, irreducible quadratic, the numerator will be a linear, function, where the coefficients of our x here will be unknown. That is what we need to find, and the constant here will also be unknown. So we'll have ax plus b. So for the second factor, which is ax squared plus 2 raised to the power 2, okay, we would have also at the numerator would be a linear function or a linear factor. We'll also put in a linear function, cx plus d, where our c and d are the unknowns that we need to find. With that said, we will go over, taking common denominator or taking LCM, taking lowest common factor of this, will also bring us back to this. So what we need to do is we'll multiply both the right hand side and the left hand side with x raised to the power 2 plus 2x, which is what we have at the denominator here. Multiply both sides with x raised to the power 2 plus 2 raised to the power 2 with the right hand side. multiply the right or the left, with the left hand side, and would have this expression. We also multiply x raised to power 2 plus 2 raised. We also multiply this with the left to the. We multiply this to the left hand side, and we have this expression. We multiply the LCM with the right hand side, and would have ax plus b, open bracket, ax plus 2 ax raised to power 2 plus 2, and when we do that here, we'll be left with only cx plus d, which is what we have here. So with that said, the left hand side here is equal to, we'll open up the brackets here. When we open up the brackets here, ax multiplied by x raised to power 2 will have this. Open up the brackets here, we would have this expression up to this point. Now open the brackets here, we'll have this expression cx plus d. So from here, what we need to do is we'll collect like terms, or we'll collect like terms. What are the likes? We'll have x raised to power 3 here. What coefficient has x raised to power 3 in the on the right hand side here? It is a. So we equate this ax raised to power 3 with 8x raised to power 3. So with this, we'll cancel this. X raised to power 3 cancels, and we're left with a is equal to 8. The next step will be to look for 0. Not having x raised to power 2 here implies 0x raised to power 2. So we can just, we'll put in 0x raised to power 2, just for clarity, and look for the coefficient that has x raised to power 2. The coefficient on the right hand side that has x raised to power 2, and it is this term here. We'll put that expression here and equate it. We'll also cancel, therefore our b is equal to 0. So with this, we also do the same thing with 13. So the question that has 13 here is 2a plus c. We collect terms cx and 2a. We factor x. We're left with, when we factor, we'll have this expression. So therefore, this can cancel, x cancels, and when x cancels, and I substitute this value, I substitute our a into this expression, we'll get our c, we'll have c is equal to 3. Now we're left with just 2b. The next constant here, that is not written, but it's, the next constant we'll have here is equating the 0 constant with every other constant we'll have on the right hand side. So we'll say 0 is equal to 2b plus d. Okay, d and d are the only constants here. 2b and d are the only constants here. We equate it to 0. Since b is known, we substitute b into this equation, and therefore we have d to be equal to 0. With that said, the partial fraction decomposition of this expression is equal to, we have our a here to be 8, so we write 8. Since our b is equal to, we have 8 times x, we write x. Okay, since our b here is 0, when we put in b here, that's 0, so we're left with 8x over x raised to power 2 plus 2. Now for this side, our c is equal to minus 3. So we'll put in minus 3 here, and our d is 0. We'll put in 0 here. Therefore, the partial fraction decomposition of this expression is this. So at this point, we have come to the conclusion of every kind of all types of problem that can arise, all types of problem that can arise at the pre-calculus level, in terms of what problem that can arise at the in this topic for a pre-calculus class. So depending on what factors or variables you have at the denominator, I believe by now you can be able to think of how to decompose or express those the numerator, such that you can be able to work out what the partial fraction of the expression you're given. With this, we've come to the conclusion of this lesson. The next part, or the next part, will be to write a formula. Or a formula or an mnomic you can keep in mind, so that when you come across problems, you can reflect to them and see how that mnomic or how that formula can help you think of how to break partial fractions into parts. I'll see you in the next one.